already did this with our degrees, right? So we already had the formulas for these. Now, the exam is coming up very soon. They do not give you the formulas for these. So you'll notice right here, these are the same formulas that we had for degrees, except for one thing has changed, right? What is the one thing that has changed in these formulas? Okay, I've got right here in the bottom of my fraction, what was that in our other formula? 360, okay? Now, these will simplify quite a bit, but I would suggest just sticking with this formula because you have to know them on the exam, right? Like, I don't get to give you a note card on the exam. They will fire me if I do. You have to have these memorized. So the only thing you have to remember, if you already know your arc length or your sector area formula for degrees, all you have to remember is that 360 equals 2 pi, and just replace that for these problems. And then you can use everything there. So I would suggest using these formulas. And it's just a fraction. So this is your angle divided by the whole circle, which would be 360, times, what is 2 pi r? That's something for a circle. What was it? It's circumference. Okay? So think about that. It kind of like you've got your fraction of the circle that you're looking at, and you're multiplying it by circumference. That gives you the piece of the arc that you've got right there. Right? So you just got your angle over the whole circle, which is 2 pi when you're dealing with radians, and you multiply it by circumference, 2 pi times r. Sector area is similar. You still have this top part is your angle. The bottom part is 2 pi, which is the whole circle. And then what is pi r squared? What is that for a circle? Pi r squared. That's another formula we have. That's your area of the circle. Okay, we might even, I'll worry about it next week. We might even have like a little quiz on a few of these formulas because you guys are very good like at doing this. You did well on these questions on the test. But I'm worried that you're going to miss them on the exam because you don't have your formula. And I would love to give you a formula sheet. I wish the state would give you a formula sheet, but I don't get that power, right? And they will fire me if I decide that I'm going to write that on the board for you or let you use that. So we can't cheat on those state tests because that'll get you in big trouble. So it's just the fraction of the circle times the circumference for your arc length, fraction of your circle times the area for sector area. So let's look at some problems here. Okay? So find the length of each arc is what they're asking us to do here. So for this, my formula for arc length, remember, was theta. And this is a theta. A lot of you are drawing it like it's a 0. That is not a 0. It's not the same as this. This is a Greek letter. It is called theta. It's just a variable they like to use for angles. You can put an x there if you wanted, but it's your angle divided by 2 pi times pi, I'm sorry, wrong one, 2 pi times the radius. That's our arc length. So, I would just do 3 pi over 4 divided by 2 pi. It's ugly, but they let us use Desmos, so I wouldn't even worry about it, right? Times 2 pi times, what's my radius? 7. Okay? It's kind of ugly, but they let us use Desmos, so I wouldn't even worry about it. Okay, and I'm getting 16.493. And that would be yards. Now, there's a chance that they give you this and it's not decimals. So let's do the second one like we can't use decimals for it. Like we got to do it by hand. So we would do the same thing for this. We would do 7 pi over 12 divided by 2 pi. 2 pi times the radius, which is 9. Now, if they make us do this where we don't have a decimal, okay, it's really not all that bad because of this one thing that's going to happen. Now, first of all, I've got a fraction here. I do not have a fraction over here. How can I make all this stuff a fraction? Put it over 1, right? Now, look at what we've got right here. I've got a 2 pi right here in the bottom of the fraction and a 2 pi right here in the top of the fraction. What's going to happen with those? They cancel out. And it happens every time they cancel out, right? It would have happened over here if we tried to do that by hand also. Every time those two cancel out. So really all you end up with is 7 pi over 12 times 9 over 1. And then if you multiply those together, you're going to get 63 pi over 12. It might reduce, if you want to reduce these in Desmos, you can't put the pi. If you do 63 pi over 12, it's going to give you a decimal. But if you do 63 over 12, it'll let you change it to a fraction. So it'd be 21 pi over 4. Now, if it lets you do a decimal, just type it in. If it lets you do a decimal, go over here, you can type it in. For that, you got 7 pi over 12 times 2 pi times 9. You can just type it in. It gives you the answer right there for that, 16.49336. So if it lets you do a decimal, that is perfectly fine. If it's multiple choice, get the decimal, then check your answer choices to see which one matches, right? You don't have to be able to do it like that. But if they make you do it with a fraction, these 2 pi's always cancel each other out. In fact, if you look at if you look in other places, some do cancel these out right here because in the formula they cancel out. And they'll just say it's theta times the radius, which does work. I just find kids have a hard time remembering that's the formula, where if we just stick with what we had with degrees, we have less to remember for that. Okay? So for number 3, our formula is our angle over 2 pi times the radius. Jasper, on number 3, what is our angle? It is not 10. Okay? in radians, typically your angle has pi's with it. It's not going to have a degree mark. And you're looking for where you've got like that little arrow right there. So this number that goes with that little arrow, that's your angle. So it's 5 pi over 4. And then 10 is in kilometers. That is going to be your radius. Okay? So, if we just type it in over here, 5 pi over 4 divided by 2 pi times 2 pi times 10. We get 39.270, I think is how that's going to round. So 39.270 kilometers. So you could always do it either way. The way that you'll know is what what it's asking for your answer. So if it says round, you can do a decimal and you would just type it in. Really, honestly, there's not a lot. Delta Math can ask you questions like this, where you're going to have to do it with the fractions. I don't think you're going to see one on the actual exam or my test where you're going to have to do it like that second one, because they could make it multiple choice, but then you could just type your answer choices in to see which decimal matches. So most cases you should be able to use the decimal, I think, for that. Okay, questions? It's uglier than with degrees, but it's pretty much the same thing that we did with degrees. It's just your angles are in radians this time. All right, let's do some sector area for this. So for your sector area, the formula for sector area is still theta over 2 pi times the area of a circle, which is pi r squared. So again, for this, we're just plugging into that formula. Let's see, Keely, what is my angle for this example 4? Good, so 7 pi over 6 divided by 2 pi times, what's the radius, Keely? 8 squared, right? And so we're just going to type that into Desmos. And it's uglier, but we'll get 117.286. And that would be square feet. Okay, so when you are typing this in, if you do 7 pi over 6 like that without parentheses, it'll kind of mess it up. So put some parentheses around your 7 pi over 6. You actually don't have to have like that other set of parentheses. Like if you do divided by 2 pi, I think it's going to work just fine like that if you do it this way. And then you'll do pi. Let's make sure it gives us the same answer. 8 squared. Yeah, it'll give you. Or I had that extra set of parentheses there, but I don't think you have to have those for that. You do, I think, need the 7 pi over 6 to be in a set of parentheses, though, or it kind of messes it up. You're welcome. Okay, how about you guys try 5 and 6 on your own? Okay, I'm seeing lots of correct answers as I walk around, so that looks good. And here, oh, oops, wrong button. Here is what you should have. So number 5, you should get 183.260. There, that's a little tricky round, and it rounds up to 6. And then 282.743 for the second one. Yep. Right here. Around that top part, or it doesn't divide it correctly. Okay. All right. Is so important for connecting things together for this. All of trigonometry has a lot of different applications. Whenever you learned about trig in Math 2, you learned about sine, cosine, and tangent. You learned about triangles. If you know this angle, then sine is your opposite over your hypotenuse. Your cosine is your adjacent over your hypotenuse. If you were looking at tangent, it is opposite over adjacent. And you can find different sides of your triangle. What is very interesting to me is we can connect these triangles to a circle. Okay? And then we can use that circle to create waves. And those waves can be used for all kinds of things that seem to have nothing to do with triangles. For example, lots of things travel in waves. You have sound waves. You have like tides, like ocean waves that you can look at. You have all kinds of things that you can look at that are sinusoidal, that follow a wave pattern. So the unit circle is the key from going from a triangle trig to going to wave graphs. Okay, so it's really important mathematically for the connection between those two. So let's look at it. Let's just start by reviewing a little bit of trig. I'm going to run through this so that you guys can see this. Please cut off whatever else you got on your computers. Let's just stick it to Desmos. That's all you should need right now, so that we don't have any unnecessary distractions. Okay, so if I'm asked to find the length of AB, that is this side, right here, right? And so I know this angle right here. That would make this side my opposite side, and 10 would be my hypotenuse. Now, those trig ratios that you learned in Math 2, you might have learned like SOHCAHTOA, or sometimes I teach my kids some old hippie called a high tripping on acid, like to remember what you have there. But sine is opposite divided by hypotenuse. So I could set up this equation. I could say sine of 35 degrees equals the opposite side, which is x, divided by the hypotenuse, which is 10. Okay, so if I do that, then I'm trying to solve for that x right there, and I would multiply both sides by 10 to get rid of it. So x would equal 10 times sine of 35 degrees, and then I could just go over to Desmos and type that in. So if I just type this in here, 10 times sine 35 degrees. Let me make sure it is default degrees here. Yep. All right. And I get 5.736. So x would be 5.736. Okay, I understand you may not remember how to do this perfectly, but does it at least look familiar? You have done this before, seen sine, cosine, tangent stuff before. What we're going to do is we're going to use this with a circle. So let's go to our next one. I'm going to skip this just for the sake of time, and I'm not going to get into that too often. Okay. All right, so we're going to connect this to circles. We're going to graph a circle that has its center at 0, 0 and has a radius of 1 unit. Okay, so this circle right here has its center at the origin right there at 0, 0, and its radius is 1. Okay, we call this the unit circle, because its radius is 1 unit. Okay, who can tell me how to write the equation of this circle? This is a review. This is from the last unit. Remember, it was x minus h squared plus y minus k squared equals the radius squared was our equation of a circle. So for this one, how would we write it? What do you think, Jonas? Because HK is your center, right? And our center right here is at 0, 0. X minus 0 squared, y minus 0 squared equals the radius squared, which is 1 squared. If you get that, the most simple way to write it is x squared plus y squared equals 1. Okay? So, we're going to take this circle and we're going to look for points on the circle. Okay? So, I've taken just a piece of the circle here and I've drawn in a triangle. And for this triangle, The only thing that I know is that this point is on the edge of the graph and that this angle right here is 30 degrees. Okay? So, if this is the point, x, y, that would mean this horizontal side right here is x. And this vertical side right here is y. Do I know any of the other sides of the triangle? That hypotenuse. Do I know that side of the triangle? It's not marked, but it goes from the center to the edge of the circle, which means it is a radius, right? What is the radius of the circle? 1. So this side right here is 1 because it is also a radius. So, this side right here would be my opposite side. This side right here would be my adjacent side. And this side right here would be my hypotenuse. So let's look for x first, right here. So I've got adjacent, and I know my hypotenuse, which is cosine, right? So cosine of 30 degrees would equal the adjacent side, which is x, over the hypotenuse, which is 1. Now, technically, I could just like multiply both sides by 1 here, or just 1. It will be for these, yes. Hypotenuse will always be the radius for these problems, yeah. So really, cosine of 30 degrees just equals x. So I'm going to go over to Desmos and type that in. And I get 0.866. Okay? Now, because I know something that you don't probably remember, I know that this is a special value that could also be written the square root of 3 over 2. Right, if I go type into Desmos to prove it to you, square root of 3 divided by 2 also equals that same decimal, right? Okay, so my x coordinate here is 0.866 or square root of 3 over 2 if I have to do it with decimals. I could show you how to get this, but it requires a lot of prior knowledge that I think we've probably forgotten and don't have time for. So just take my word for it right now. If you want to know big time, come see me elsewhere, and I'll show you why. Okay, so that x coordinate is square root of 3 over 2. Now let's think about the y. Okay, the y, to find it, we would have to use sine because we're doing opposite and hypotenuse. So we would have sine of 30 equals y over 1. Solve that one for me, and let's see what you've got there. Started on the second one, but I haven't tried it. I was thinking, I'm going to get that for Christmas. I'll see if I get that done.
Yeah, so she was saying she might try and
Yeah.
I'll be around the 16th.
Okay. Yeah. And I may send it to you. This one like this. Question. So, yeah. I know we were thinking about so I may send it to you before I Yeah, thank you. All right. Yep. Okay. It has switched to, yeah, so you need to pi 9 squared instead of, yeah, it was that one. Yeah, so you were using the wrong formula for that one. Because I think at number 11 it switched to active for sector area instead of heartless. Okay. All right. So, oh gracious, my computer screen went black. Still works up there. Okay. All right. So, when you get this, you get sine of 30 equals y. What was sine of 30 when you typed it into the calculator? 0.5. Or if we wanted to do a fraction, it would be 1/2, right? So the coordinates of this point right here are square root of 3 over 2 and 1/2. Okay, so we will be adding this to our unit circle document come Thursday. We got to do the check-in tomorrow for that, but this is where it comes from.